17. Was there a particular part?
Yeah, so for the for 2 plus to get to the fraction 1 over 2n plus 3, I just I was wondering how you would do that.
Oh, this part right here?
Yep.
So you're okay with... Oh, I thought I was using the other thing. Ha, ha, ha. Are you okay with this part?
That part, pretty much, yeah.
Okay. So let's start with that then. So think about what 2n plus 1 factorial means. That means start at 2n plus 1, and then we just decrease 1 every time and keep multiplying. So if we decrease 1 from that, then we're at 2n. Decrease 1, we're at 2n minus 1. And we just keep going down until we get to 1. So that's the numerator. Now if we did the same thing with the denominator, 2n, I don't know why I wrote that all the way over there. Anyway, if we do that, then that means start with 2n plus 3, and then keep decreasing by 1. So if I decrease by 1, I'm at 2n plus 2. If I go down by 1, I'm at 2n plus 1. If I go down by 1, I'm at just 2n. And I keep going until I'm down at 1. And then we can see all of this will show up right here. Does that make sense? You're welcome. Sid. Yes.
So I think number 3.
Oh, wait. Different problem, you said.
Yeah.
And Kim, yours was a different problem, too? Okay. All right. Problem 3. Yes.
Yeah, if you could just go over how that, like the E thing and how it fits into that problem.
Like how I got the 1 over E?
Yeah,
Or
like how you kind of related. You said like the definition of E is that thing, so I was wondering how exactly you...
So the definition of... Are you seeing it now? Oh, I have it right here. So this is the definition of E right there, which is just this part inside.
and it's the negative 1 over that.
Exactly.
Okay, got it.
All right, Kim, what's your question?
Number
15. Anything particular here?
the LA part.
That's kind of all over the place. So is it the whole thing? Because the whole, like we,
Second line,
the second,
limit of,
this part,
yeah.
this line. Okay, so what did I do? Let's see. So I put those together, and so I'm looking at the limit of this and the limit of this, and this part right here is going, it's infinity over infinity, which is one of the indeterminate forms that we can use L'Hopital on. So I took the derivative of the top and the bottom. L'Hopital! Ha ha! There used to be a time when L'Hopital's rule wasn't on the AP exam, which was the silliest thing. I think almost every AP teacher still taught it because it's just so much nicer. Any other questions? Hey, Don.
The limit of second part and the third line.
Oh, yeah, you're right. I did leave off. Thank you. You are correct. There we go. Thanks. Any other questions? Yes, Sid.
How do you evaluate that limit? The limit at n, what's the value of the 1 over the, isn't that like 0 to 0?
Well, yeah, but I mean, so the part that I did in my head was multiplying. So dividing by the fraction is multiplying by the reciprocal.
Yeah.
And then it's just the leading coefficient over leading coefficient.
Right.
Any other questions? Can I have your homework then? Ah, invisible homework. That's my favorite.
Yeah.
Just looking for the name of the in the corner.
Hey, guess what? what? Guess what? We have one. Yes. Yay! We get to do a reality check. Woohoo! I saw that. Thank you. At least that's on the original. All right. We're gonna go 6 minutes on this one. 3 questions. I know, but the fact that he has to do math at 10. No, that he does. Although, one of my favorite college professors, he's the one who turned me on to math test. He did his math at home. I think somewhere there's extra one. You guys are short one. Did some row get an extra? There's no extra one? I don't know where the extra one is. Can you pass this one? Wait, you all got one? Oh, I thought. Never mind. All right, so you guys get 6 minutes. You may begin. Any questions? Where? So A, hopefully we know from last night's homework, A doesn't have to be true. It could be, but if the ratio was just anything less than 1, it's going to converge. So it doesn't have to be 0. The limit of the ratio doesn't have to be 0. This one for part B, the key is the for all n. I mean, maybe we start with numbers that are bigger than 1, and then eventually they tend to 0, or they just, get smaller. But the fact that it had the for all n, that's what kind of messed this one up. Just because something converges doesn't mean that the sum is 0. In fact, most often it's not. And then as far as D and E go, E is easy to explain because, if the series already converges, if we divide by something bigger than 1, which n is always going to be bigger than 1, it's just going to make it even smaller. So that makes sense that this converges. Think about P series for D. If A sub n is 1 over n squared, the summation of 1 over n squared will converge, but n times this doesn't have to, it diverges. But if A sub n was 1 over n cubed, then n times the A sub n would be 1 over n squared, which still converges. So must be true. D does not have to be true. So, any questions on that? All right. There's number 2. We don't need all that. Those are my distractors. Blah, 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 blah. That's just the one that says if the terms don't tend to 0, it's going to diverge. It doesn't say anything about convergence, but it just says if... wrong thing. As n gets bigger, this fraction is just going to keep getting bigger. It doesn't go to 0. Any other questions? Then number 3. Oh, again, my distractor's over here. You don't need that. So I tried to color code. For the first, this inequality makes it converge, which is this part of the number line. For the second series, this inequality makes the series converge, which is that part of the number line. So it's this part that makes both of them converge. And that's the inequality we're looking for. Oh my God, stop playing Wordle.
Oh, did you get it today?
Yeah, but which version are you playing now? Because apparently, I forgot to download it, so I'm doing New York Times version. Yeah.
How many tries?
4 or 5. I think it was 5.
You got it in 6.
Wow, so mean. I got it in 4. All right. Let's do some notes then. Yay! Oh my gosh, this sounds like so much fun. Oh yeah. Oh yeah. Oh man. I meant to erase all that and then write it with you, but I guess since it's here, I'm going to take advantage of it. Not really. Although with the minimum day, collaboration day, I don't know how much extra time we'll have. While you guys are writing that down, I do want to make sure some other stuff is erased. Yeah, I definitely want to erase it. Oh, and see, yeah, I got like half of... Sometimes I just hate this thing. Oh, well. You guys write. I'll explain in a moment. Yeah, I guess it's just that one other part then. Oh, well. Okay. Boop. If anybody watches the video, you can see it going up and down and up and down. What the heck is she doing? So now we're done with our tests for convergence. Now we're going to see what some of the stuff we can do with this. Luckily, though, this first page is where a bulk of the non-example part is. Most of today's notes is just examples. Yes, Joshua. What's what? Oh, got it. I forgot that covers it. Godzilla. Try to plan out the spacing of what I want to write ahead of time. But then I try to erase it before we start. Does anybody still need that first bubble? Okay. Because the second bubble's a little long, so there's the second bubble. Bubble. Bubble's a fun word to say. Bubble. It's almost like you want to keep saying bubble, 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 bubble. We're gonna take a bubble, bubble, bubble bath.
Did you say you can't say bubble with an angry voice?
Bubble.
It doesn't work.
I think I did it. Let me talk. Oh no, wait, I'm recording. Look, I filtered myself. You better not have been recording. I'm getting better at filtering myself. That's one of those, personal journeys I've been on. I'm from New York. What can I say? I'm not actually from the city. I'm from upstate, but still, East Coast, man. You guys on the West Coast, you watch what you say. You're delicate with your words. Oh my God, it's so exhausting. I don't know how you guys do it. I've been out here 20 years and I'm still not used to it. Actually, 22 years. Holy crap. It's very tiring. Anybody plan on going to school on the East Coast? You're going to enjoy it. Yeah. Where are you gonna go? All right. I went there 1 year, 1 year, but turns out I'm not a city girl. Who knew? I didn't know. Boston's cool though. My niece is there. Maybe if I go visit my niece, I'll look you up. That would be fun. At least for me. I don't know about for you, but how many people are still writing? Okay. I'll stop distracting. Sorry. This is very exciting watching the video. I should have been pausing this. Sorry for people watching the video. I don't know if anybody will. Seems like everybody's here now. I haven't looked at our attendance. Actually, I'm going to pause. I will scroll down in a moment, but just super quick. All the first part, hopefully the first part looks familiar because that's similar to the Taylor series we did before. We didn't spend too much time on this because then we jumped into what it would look like for a Taylor polynomial specifically. But in general, anything where each term looks like this, where you have this x minus c to the power of n, and remember what does it mean again to be centered around x equals c? Yeah, exactly, very good. Yeah, the closer you are to c, the better that this is going to be an approximation for it. And what we're saying, notice this is not saying approximation. This is actually saying exact now, because we're talking an infinite series. So so we're just saying that a power series, and not everything can be represented by a power series nicely, but the things that can be. Now, this part, the radius of convergence part, this is the part that we actually care about, though, because how close do you have to be to c to actually get that infinite series to be equal to the function? When does it actually converge to the function value? And that's what the radius of convergence is. And I'm just going to jump down to here. Actually, we kind of have this. So it's one of those three things that are going to be true. And so here we are at C, whoops, and we have this thing called the radius of convergence. And the reason why it's called the radius of convergence, you can see by this picture. So going around a circle with a radius of r from the thing that you're centered at, the radius of convergence is the values of x that series will actually converge to. How close do you have to be to C? So you can be r units away from C, plus or minus, and the series will converge to the actual function value. So maybe number one says it only converges when you're actually at C. Well, if we can't go plus or minus anything, if we have to only be at C, then the radius is 0. Or maybe it actually converges for all values. And if that's true, that means I can go infinitely far to the right and infinitely far to the left. My radius of convergence is considered infinity in that case. Or maybe there's a fixed interval that it actually converges to, and we just say that the radius of convergence is r, and I'm going to show you how to find r today. So, any questions what this is saying? Okay. So let's take a gander then. Here is our first example. I will let you write that down. We got 3 different series that we're going to work with, 3 different power series. We're going to show that the radius of convergence is the same, but the interval of convergence is different. What? It's crazy. Madness. Madness, I tell you. You can see the 3 series are almost identical, except I'm just multiplying by an extra n each time in the denominator. And how does that change things? No, right? So I know some of you guys are still writing this down, but we'll start looking at it. I'm just going to write A first. Let's look at A. Actually, I want to use purple. Purple. So, we're actually going to use something you guys did last night, if you actually did the homework. Something about he had like a mock trial tournament. I don't know. Seems like a lame excuse, but whatever. Anyway, we're going to do the ratio test. Just kidding. Sorry. That's what we often use, the ratio test. So, I'm going to let a sub n equal that argument, x to the n over 3 to the n. Then, according to the ratio test, we're going to use the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. And then we're just going to start working it out. So if we plug in a sub n plus 1 is x to the n plus 1 over 3 to the n plus 1, and then multiplying by the reciprocal of a sub n, it is times 3 to the n over x to the n. And when we simplify that, what does this fraction simplify to? Kieran. Say it again. 1/3 x, exactly. First I thought you said square root of x. I'm like, I know that's not what he said. Got it. So what is the limit as n approaches infinity of the absolute value of x over 3? Yeah, but it's still absolute value, though. There's no n, so it's acting as if it was a constant. It's going to be whatever the absolute value of x over 3 is. Obviously, it depends on the value of x, but whatever that is, no n. And from the ratio test, we know that the series will converge when that limit, the absolute value of x over 3, is less than 1. So now it's giving us something to work on. So any questions how I got here? Yes, Sid.
We also looked at it as like a geometric series, because it's like x over 3 to the power of n, and then we know that for that to converge, it's like, we know that the inequality limit.
You're right. For the other two, though, we can't, so this is a process in general you use, but yes, you're right in this one. It's just a geometric series. Now, I'm going to go back to looking at the original one. Can you guys tell me, looking at the original series, the way this is written, what is our value of c? What is this centered at? Yeah, it's centered at 0, because it's like we have, oh, that's not what I wanted. It's like we have the summation as n goes from 1 to infinity of x minus 0 to the n over 3 to the n. So this is centered at c equals 0. So going down here, think of this as x minus 0 over 3 is less than 1. And then we know that negative 1 is less than, whoops, sorry, I meant negative 3 is less than x minus 0 is less than 3. So here's my x minus c right there. So we can see x minus c in the middle, and we see that we're going plus or minus. Actually, let me even write this further. This means it's c is 0, so I could do 0 minus 3 is less than x is less than 0 plus 3. My radius of convergence is just 3. We usually don't go that far. I mean, usually just from this line right here, we can see the radius of convergence is 3. We're going plus or minus 3, but just to kind of show it even more, and if you compare it to this guy right here, you can see that in place of r is 3. So we can say that the radius of convergence is 3. So as long as we're 3 units away from c, in this case 0, the series will converge. So any questions so far? Yes.
Is there a reason we use ratio test and not root test?
Ratio test is going to be the one that's easier to work with. You could use the root test, and this is one actually, again, because we do have it all to the power of n. Yeah, the root test could have worked too. But in general, it's going to be the ratio test is the easier one. Okay, so what is the interval of convergence? Well, the interval of convergence is where we have to check the endpoints. What about if x equals negative 3 or 3? Because remember, the ratio test is inconclusive when that limit is equal to 1. So we can't rely on this process for the endpoints. So you actually have to check the endpoints manually. So now we're going to check the endpoints. And here's what I mean by that. And the endpoints of the interval are -3 and +3. So when x is -3. Now remember, our original series was x to the n over 3 to the n in the summation. So I'm going to just write that so we have that visual. And I'm going to substitute. I'm going to let x be -3. -3 to the n over 3 to the n, as n goes from 1 to infinity. How do I check this one? Now we're all experts on all these different tests for convergence. Kieran? If we cancel out the 3 to the n, what are we left with? So you're right, but you're wrong. Yes. And the reason for that is if I rewrite the numerator like this, oops, like this, then we can cancel out the 3 to the n's. And so it is -1 to the n. So, yep. Divergence test is the easy one to see that this diverges. The series diverges by the divergence test. All right, endpoint number 1, check. Let's check +3 now. So I do the exact same thing. Put in a +3. And this one's much easier, but can you guys see, is this going to converge or diverge, and why? Converge or diverge? Why? And so what test are you going to use? Yeah, again, divergence test is super easy on this one. This is going to simplify to the summation of 1, which, again, diverges by the divergence test. So, now we can say the interval of convergence is -3 to 3, not including the endpoints. Be very careful on the wording of the question. If it's asking for the radius of convergence, it just wants a number. If it's asking for the interval of convergence, then obviously that's an interval. But don't answer the radius of convergence with the interval without actually saying 3 is the radius of convergence. I get that a lot. And yeah, I mean, you might say it's obvious from this interval that the radius is 3, but if people don't actually answer r equals 3, I can't give full credit. So, Sid. Any other questions? All right. Well, your task is go ahead and try B and C. Do the same process we just did on part B and C and see if you can show that, yes, the radius of convergence is still 3, but the interval of convergence will be different. So exciting. I shall pause the video now. So there's the work for it. Again, we knew what the radius of convergence was going to be, but sure enough, oh wow, look, P related to get 3. So any questions, though, on finding the radius of convergence? So obviously, if the interval of convergence is going to be different, it has to converge at least one of the endpoints. Anybody figure out which one or ones it converges to? Greg? Yay! Yes, it does. Excellent. A little note on showing work. I will try to be as clear as I can on my test and the directions, because notice I just said converges by the alternating series test. I didn't actually establish that we had an alternating series. I didn't say that the absolute value of the term is decreasing and goes to 0. Like, I didn't say anything about the conditions for the alternating series test. If this is the AP test, I honestly don't know if they're going to want you to do that. So my recommendation is, it takes a lot of writing. If you got time, write it all out. If you don't have time, make some sort of note to yourself to go back and fill the conditions in, but just go ahead and say like what I did, converges by the alternating series test, and move on. Then, after you've finished all the other problems, if you do have some time to go back, go ahead and fill it in. I honestly don't know. I don't know what the AP test is going to be. On my test, if my directions are not clear, like I said, I'll try to make them as clear as I can. But there's still some, as much as I try, there's still always somebody who's like, I don't know, do I have to write the conditions? Just feel free to ask me that during the test, and I will say whether or not you have to state the conditions for the test or not. But with that said, any questions? All right. Do you want more time looking at C, or do you want to just, you want to try C a little bit more? I'll put the radius of convergence part up because that's not a surprise. There's that. We already know that. I'll give you like another minute to check the endpoints. Oh, there's my clock. Like, where's my... I have too many watch faces. Godzilla. Oh no. They say he's got to go, 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 Godzilla. Woo! Here we go for checking the endpoints. It's going to converge at both of them. We can use the alternating series test on the left, P-series test on the right. There could be other tests to use, but these are definitely by far the easier of them. So any questions about that? So we do have one other little thing. It's kind of cool, but one other little thing. Does your head hurt? Is it starting to ooze out of your ears? That'd be gross. Earwax is gross. Anybody ever get one of those earwax jelly beans? They are awful. I don't know. I don't think I want to know. Made with real, genuine earwax. All right, does anybody still need this? All righty. So let's look at this. Pay no attention to the example. Well, I guess you can write the example down too. So let's go back to geometric series for a moment and look at them in relation to power series. So remember, if we have this geometric series, one thing I do want to point out, because pretty much like the vast majority of our problems we've been doing have been starting at n equals 1, but now I'm saying n equals 0, and we got to start at 0 for this formula to be true. because remember the numerator in this formula is the first term. And to get the first term to be 1, we need to make the exponent 0. So very important that you write this down, n equals 0. So infinite geometric series, we know that this is a sum it's going to converge to as long as this is true. And then just make the R and X. And we get the cloud, the formula in the cloud. And that becomes a nice way of writing something like this as a power series. Any questions on the cloud? I mean, I know you're probably wondering how are we going to use this, but can you at least follow how we got the cloud? Whoop. All right, let's see how we do this. The first thing, in order to take the series that's given to us and write it as a power series, we need to put it in the form of the cloud above. So here's what I mean. We're going to start with f of x equals 1 over 16 plus 2x cubed. And we're basically going to use this cloud like a formula. And when you use a formula, you just have to figure out what you're going to substitute in place of the variables. This formula really only has one variable in it, x. I mean, it's got the n, but the n's already defined. So we just have to figure out what we're going to put in place of x. And that means we have to take this function and make it look like 1 over 1 minus something. All right, so here's what we do. First of all, that is a 16. That is not a 1. We need to fix this. I will factor out a 1/16. And that will get us 1/16 times 1 plus, and then it'd be 2x cubed over 16, but that simplifies to x cubed over 8. So I got the 1 where I want it, but now I got a plus sign where I want a minus sign. Dang it. That's all right. I'll just make it 1 minus a negative x cubed over 8 instead. And there we go. Problem solved. Now I know what I'm going to put in place of x. And I literally put that in place of x. It's quite lovely. So any questions just how I got there or why I did that? All right. So now I can say that f of x is equal to, and I've got that 1/16 coefficient. I can either pull the coefficient out in front of the summation or have it inside the summation. I mean, eventually it's just going to come out anyway. So I'll just put the 1/16 out here. And then it is the summation of negative x cubed over 8 to the power of n as n goes from 0 to infinity. I replace x with a negative x cubed over 8. But that's not all there is to the formula. Oh no, because it also says if the absolute value In this case, we're going to put negative x cubed over 8 is less than 1. Godzilla! There it is as a power series. Now I'm just going to clean the absolute value part up a little bit. But any questions what I did here? Because yes, you literally just do that. Alright, so we know the absolute value of the negative. I don't need the negative anymore. I'm going to go ahead and I'll just write it like this. Probably already see where this is going, but if I multiply through by 8 and then take the cube root, I get negative 2 is less than x is less than positive 2. Now I know the directions just specifically ask for the radius of convergence. By the way, what is the radius of convergence? 2. But just in case, I'm going to put all this stuff down. The power series for f of x is the summation at, whoops, actually, sorry, I forgot the 1/16. 1/16 times the summation as n goes from 0 to infinity of negative x cubed over 8 to the power of n. But it's only going to converge. This is only a power series for f of x as long as the absolute value of x is less than 2. So I've just simplified the absolute value part. So if the question asks for the power series, that's the power series. Yes? No, and I'm getting there, but we don't. That's the best part. If the question asks for the radius of convergence like this one did, you guys already answered that. The radius of convergence is 2. And yes, here is the best thing of using this formula. The interval of convergence. It's using this formula, it's never going to converge at the endpoints. So the interval of convergence is negative 2 is less than x is less than 2. Yes! That is so much less work than the other problems. Yes.
So it says that I'll find the power series of f(x). You only have to change it into the form, not everything else.
I don't know what you mean by not everything else.
Like you only find that radius of convergence.
Oh, right. Yeah. So the answer to the question of find the power series is just this part. The answer to the radius of convergence, just this part. The answer to the interval of convergence, just that part. Any other questions? That's all we got. Yay! So you have 6 minutes. Sorry. Good luck on that chemistry test coming up.